Hello everyone, I'm Bradley Sward, and this is my Day 20 Part 2 solution to the 2024 Advent of Code. The problem is called race condition. I'm solving the problem again, almost as always in Python. So for Part 1 of our problem, we have a windy, it's not even a maze, it's just a windy path. And the idea here is, can I go through a wall and get myself closer to where I'm trying to go? So in a lot of these cases, for part one, the answer is yes. I'm allowed to move two spaces before I have to worry about phase shifting and ending up in a wall or whatever. And so for part one, it was basically, that you can save a lot of different, there's a lot of different cheats. And for mine, there were 1,518 cheats that could save me at least 100 picoseconds. And so now for part two, instead of me being able to walk through a wall or to walk through 2 units, we're going to be able to walk through up to 20 units. And so that changes a lot of what we're doing here. And they just wanted to make sure that the starting and end position is all that mattered. You can take different paths to get there. We don't care. But the cheat is only from starting position to end position. And I don't have a solution here in the moment. What do you know about that? I will have one in about a minute if I did everything correct. So we're right here, maybe a couple minutes here. So part one is the same, or part two is the same as part one here, where I'm taking my list, and I know now I could just generate this as a map. I don't even have to use this or a set basically, just to kind of speed up the process here, because everything as a list is going to be much slower. That's okay. That's just the way life goes. How to improve things and make things a little faster. But anyway, it's the same idea, and then I go through and I create the path, a vector, or a list of points in space. And then basically what I did for part one is the longer in the path, we just figure out the index value, and that's the distance between the 2 points. And then if we moved around and whatever point was closer by more than 100 units on there, then we know we have a winner. And so now this is the big part here. This is the big change here, because it's like, okay, now that I can move 20 spaces, well, I can move 20 up, 20 left, 20 right, 20 down, and everything in between. And it becomes either, if you want to think of it as a diamond from a perspective, or just a square turned on its side for the number of spaces that you can turn. And it turns out if you go 1 plus 2, or 1 plus 3 plus 5 plus 7 plus 9, all the way down, and then kind of repeat the process, you get 841 different values to try. And that's what this is saying. Start at negative 20, 0 at the top of this thing, and give me one element. Start at negative 19 and negative 1 and give me 3, and then go over here, give me 5, and then give me 7 and 9, and then it works its way to the middle one, which is the biggest one, 41, and then it works its way in backwards. I just so I don't have to write it out, I just turn the negatives positive. And so the code was basically the same, just understanding that, and also just making sure that now that, because before 2 was the hard-coded value that we could use, well, now it totally depends on how far away from the original position this point in space is. So I just had to write a little extra code to handle that. Basically just figure out the delta x and delta y positions from using this kind of array structure, and then basically add this on Manhattan style at the end. How much have you moved to get from where you are to where you're going, so that we can account for that in our subtraction here. And we'll have our answer here in about less than a minute, question mark. So let me pull this up. Let me pull this up to the side here. And let's do this. We'll have our answer here in a second, and we'll have a huzzah, and we can all move on with our lives, right? So let's see, what is our answer? And the answer is whatever, a million something. Oh boy, here we go. Here we go. And it's right. So there you go. There you have it. That's a solution to. I'm not proud of it. It's brute forced. It took me about an hour and 10 minutes to create the solution. But you know what? I have a solution. I'm ready to move on. Not all of them can be winners. So thanks for sticking it out with me as always. Have a great day, everybody. Take care.